So this topic is we discussed in the past years with Paul Tapponnier. So maybe some of them are he agreed, some of them are not. So I want to finish this topic. The main topic is just we will show maybe Tibetan Plateau is the only limited extrusion eastward, not so large, and then maybe not like the channel flow, maybe only the middle. So maybe first maybe I just brief review the existing models. There are a lot of the models you can see in the past, related to the gravitational collapse, lateral extrusion, and channel flows or local channel flows, and a lot of them. And others. And also maybe there are a talk today by Jiao, how to explain the arc Himalaya. And also in recent, they think there is other explanations for the slab subducting and splitting. So, but most of important, maybe for a Chinese pioneer, we should remember, for the beginning, they studied the plateau. One, the Chinese guy is Mr. Chang Chengfa. His main point of the view is that the plateau had been formed by the accumulation of the multi-blocks in the past, during multiple stages and periods. And others, two falling gas should be remembered. One is Paul Tapponnier. This shows his PhD thesis. Just mentioned, use the spot image to explain the Asia tectonics. And another one is Peter Mona, the host of the Paul Tapponnier, to do did the postdoctor in MIT. And also, these two guys, they are fighting. And this is a good thing. Fighting makes the Tibetan Plateau becomes a very, very hot topic in the past several decades, years. And many models, maybe only can divide two of them, two end member models. One is upper mantle and lower crustal flow. Maybe before that is a distributed deformation of the whole Tibetan Plateau. Another one, the representative is the Paul Tapponnier. The block-like two stages of the Tibetan Plateau evolution. And then the block-like, the recent stages, the block-like motions eastward, large-scale extrusions. But in recent years, we did a lot of the works to show you maybe some evidence didn't support the channel flow, the low cluster flow. You can see after the winter earthquake around the Roman Sun, we used the post GPS monitoring data. They got the viscoelastic behavior. This is not so soft. Maybe didn't support the channel flow. And also after another earthquake, just the source of the winter earthquake, this one, Ludin earthquake. And also we use the GPS monitoring post sleepers, and also go to the lower middle cluster, lower velocity layers. His viscosities are not so low. So this is one of them that they didn't support the. Another one is the lower cluster velocity. They are not continuous around the in the Tibetan and the Tibetan Plateau. You can see this is just the southeast of the Tibetan Plateau. The velocity is Vs. Maybe there is a local distribution, and they are not connected each other. Another, the neighboring is the resistivity structures. We can see also not so connected to support the lower crustal flow. And this is a local large-scale velocity distributions. And we can see this is a low velocity bodies, but between them, there is a high velocity. So that means maybe low velocity layers support the local channel flow, but doesn't fully support the channel flow. But the Tapponnier models maybe are not so correct. We need to improve that. One of them, the questions is that maybe not so large scale eastward extrusion. We can't find that. You can see Amphithéâtre maybe since blocked by the Alasan very stable terrains. And also others, the South China blocks are also there, maybe blocked the southeastward auto expansion. And maybe and also others, in the southeast plateaus, the initiation strike slip faulting in the Yunnan regions started at the 35 million years. Earlier than the 20 years in the east of them, 22 million years. So maybe are not so perfect model. We can see next topic is that we just see there is a very uniqueness of the mega active tectonics in the Tibetan. These figures just improved from the Paul Tapponnier's publication in Science. And we can see from these figures, we can see, this is in this century's large mega earthquakes occurred around in the Tibetan. And we can see there is a differential showing differential tectonic deformation. The convergence or cluster shortening just occurred around the Tibetan Plateau, especially the east margin, He corridor, Qilian mountains and He corridors, and Liupanshan here, and Longmensan 2008. there is a large earthquake occurred. So we can see, and then there is also very large strike slip faults. These strike slip faults, maybe we can see the slip rates changes regularly from the west to the east, also showing no large-scale extrusion. And then we can see the normal faults occurred in the West Tibetan plateaus. And this may be accommodating the east block motions, eastward motions to form the extension, local extension. We can see the thrusting. Just this is the south margins along the Himalaya. This is from the Prof. Tapponier's research group, and showing each large earthquakes occurred are thrusting faults. And the Roman Sun, the eastern margin of the Tibetan Plateau, also showing these earthquakes showing the cluster shortening, dominated. And then we moved to the larger scale strike slip faults. The strike slip faults, Altin-Tag fault, this one, the most of the strike slip faults, or also we can see the Altin-Tag thrusting just in front of the strike slip faults. We can see this fault, the slip rate changes regularly. And the middle to the west, it keeps 10 millimeters around that millimeters per year. And then only passing to the Shubei, the east point, the slip rate decrease abruptly. So why? We find this is the strike slip faults from the west to the east are transformed to the thrusting, the transverse thrusting. That means the horizontal motion transformed by the transverse reverse fault to the uplifting of the range uplift in the Chilean mountains. Each triangle means the slip lost. This is a common for another large strike slip fault, Quinlan fault, East Quinlan fault. We can see the west, middle, and the west is keeps the 10 or 12 millimeters per year. And then there is some transverse branches. It decomposed the main slip and lost their slippers eastward. Even in the Sichuan and Yunnan regions, we can see the Xianshui and the Xiaojiang fault. There is other transverse thrust, Lijiang-Xiaojiang fault. We can see this fault also absorbs some horizontal, southeast horizontal slip. And the slippers from this, after this fault, becomes lower. So from these phenomena, maybe we can propose a new models owing to the very high stable, very stable terrains, the Talimo basins, and the east very stable terrains blocked the eastward propagation. So there is between them, the plateau and the east stable blocks, there is a transverse reverse fault developed. So these transverse faults reverse force transformed the waste horizontal slip to the uplift and causing the cluster shortening and uplift along the margins of the Tibetan Plateau. And this is also conflicted with the GPS results. The present motions, you can see around the east boundaries is shortening and uplifting. And the Baroque motion, eastward motions just restricted in the east Tibetan plateaus. Owing to these blocks moves eastward, they are behind. Their causes local extensions. So, and also from a GPS, we can see also fitted these models. We can see the uplifting rate very high along the margins, And also the erosion rate are high along the east margins since there are uplifted high, more highs. And these models also, we can see the focal mechanisms are similar, are very good. You can see around the margins, most of them are reverse faulting. And in the east of them, most of them are struck slip faults. And in the middle to the west, owing to the local extension, it's normal faulting events. So maybe we can divide it, the block in the Tibetan plateaus. Maybe this can fit the present and in the recent tectonic period. This is a new division of the block motions. So maybe we need to make some progress on the shoulder of the fault Tapponnier. So this is conclusions. Maybe I just left here. Thank you.